Hello YouTube, I'm coming to y'all to show y'all a little bit more about the homemade Go Devil that I built. It's used to be a stock 670cc Predator engine from Harbor Freight. I've just finished all the dual carb mods on it, got my control box built with my running lights, pods, and 40-inch light bar on the front. It's at the finished stages of being complete. It's not all perfect and pristine yet. I'm gonna take this exhaust clamp, chop those bolts off, make something a little bit prettier. That was more or less just to hold it to keep the straight piped exhaust that I made from rattling and tearing up the block of the motor. I used to have 3/4 inch ID metal bushings here, one in the center, and then one at the top right behind the U-joint. And I actually had, you can see them here, drilled and tapped holes 1/4 by 20s. That way my grease certs and my set screws ran on the same size hole, same thread pattern and everything. And I had a problem with the set screws. Even with Loctite on them, they still wanted to vibrate out. So I got away from the metal bushings, deleted the center bushing altogether. I'm going to fill the holes, weld them up, grind them smooth, make sure I don't get any on the shaft. I'm going to pull the shaft out before I do any welding so I don't warp the shaft. And you can't see at the top here because this one doesn't have a lip on it, but the bottom one does, to seal it from salt water and brackish water and everything that I deal with where I duck hunt at. It was 1.5 inch solid stock Teflon that I got off eBay for, I think 2 feet was roughly $50. And I put it in the lathe at work, machined it down to where it had about 2 to 3 thousandths press variance on the top and the bottom of the shaft. Like I said, the bottom is sealed. The top, I didn't worry about it too much. I keep this pressed with grease. I give 1 shot of high temp bearing grease to each of the grease certs and the one in the U-joint each time before I go out, just to keep it all lubed up. But to give you all a rough overview, just a standard plate for base plate. It's 1/4 inch carbon steel. The mount system, I actually took C-channel and use C-channel as a base plate. It hinges here off of this pin, which goes through a pin set here. This lifting block was strictly for testing purposes and ended up working out pretty well. Lifting block helps to pick it up to help balance the motor some. You can drive this 22 horse motor with one hand easily. Deep water, shallow, in the mud, no water, really doesn't make a difference. I tack this plate up here for whenever I'm at the boat ramp and I'm going to load up the boat. Keeps it from wanting to tilt too far back. Doesn't want to stand straight up in the water then. It kind of holds it at a median level, but it doesn't take away any of the digging ability whenever I'm in shallow water and I really need to dog on it. It's just a 3/4 inch bolt here with a lock nut, a washer on top, and a washer in between the C-channel and the bottom of the base plate to allow it to swivel. I keep it lubed up with just a little bit of grease every now and then. It never really hurts it any. As you can see, what differs my motor from most people's is I actually turn mine around whenever I'm running down the road. I took some aluminum, welded it there, and this is just aluminum diamond plate that I stitched to the bottom of the boat. Made an aluminum L bracket to weld to it, just ran a pin through there. I'm eventually going to cut this pin off. Like I said, it's not pristine and perfect. I don't need anybody bashing me for, some half-finished products. Like I said, I'm still in the testing stages. But just to keep it from rattling, holds it tight, doesn't let it move. The scag used to come up about to where the battery is here, because I took measurements whenever I first built this off of a forum online. The guy said the longer the scag the better. I figured that out to be a lie. Go with a small skag. A long skag on a longtail motor makes it very, very hard to control, especially in turns. It wants to fight you the entire time. Just not worth the hassle. Save yourself the trouble of doing it. The skag is 316 stainless. The cavitation plate is 316 stainless. I guess you would call that, the casing for the shaft. It is carbon steel, but it is galvanized 1-inch OD and 1.318, I believe, ID, 1-inch 318 thousandths ID, galvanized heavy wall pipe, Schedule 80. I actually said 1-inch OD, but that's not correct. Anyway, about 1.5 inch, 1 3/4 inch OD. It was just some old pipe I had laying around, so I didn't take exact measurements on it until I went to machine the bushings. So, like I said, sorry about the misinformation. But I used 308 TIG wire to TIG the 316 to the carbon steel on the skag and the cavitation plate. I've got another piece of carbon steel down here as support for the cavitation plate. I also, whenever I originally made this, as you can see here, this has been cut. I had the longer skag, and my cavitation plate actually curved down on the sides and continued out all the way out the back. And I found that by cutting that side off on each side and trimming it to more of a slimline feature, it really helps with picking up water, especially whenever you're in a really, really shallow situation. It's like it wouldn't get enough water to the prop to push the boat without the skag being cut down. So, tip to anybody who's doing this kind of build: make your skag very manageable and make your cavitation plate very manageable. Like I said, big pin here, 3/4 inch solid stock for the tilt pin. This interesting. Had a guy stop me at the boat ramp a couple weeks ago whenever I went to test it for the first time. After I put the dual carb setup on it. I know I talked about that before in my other video. I built custom flanges. These are bolt ups to the original flanges that went into the head of the motor. And I found that with the EPA restrictions and all that good stuff that they regulate whenever they ship these engines out that they have to meet to be produced in the US, it really limited the motor, especially on takeoff, acceleration, whole shot, torque, everything but top end pretty much. And it would bog really bad. It didn't really have the pickup that I thought a 22 horse should have. So I took the original intake completely off. If y'all want a go-to video on, gives you plenty of insight on that, check out Go Power Sports. They have a video where they made a 670cc engine into a go-kart, and they did a dual carb setup, and I wish I would have watched that before I went through all the heartache and trouble of building these myself. It would have gave me some good insight on it instead of all the troubles that I ran into. But these are 22mm Makunis. I ran 3/4 inch ID thin wall pipe here. The flanges are made out of 316 stainless. That's an 1/8 inch thick. Like I said, carbon to stainless 308 wire Heliart. Then the carburetors with this straight shot design, where it comes straight from the carburetor into the motor, straight out the back through straight pipes. The whole shot and the acceleration aspect, along with the torque is phenomenal. As far as improvements, the whole shot and acceleration has definitely exceeded what it was before. Of course, top end, no matter what anybody tells you, top end on these motors runs off of RPMs. It doesn't matter about how much you're pushing, how much, they always say there's no replacement for displacement. That's not necessarily true with mud motors. Whether you're running a 35 horse or a 5 horse, 4,000 RPMs is 4,000 RPMs. You're not going to get a lot of top end improvement off of the dual carb setup, but your acceleration and your torque is where you're going to notice the most increase, because now you're straight through design. Each cylinder is getting its own tunable key word, tunable mixture. I played with tuning the carbs. I have a vacuum pump that tells me my displacement as far as air to fuel ratio. I've done the test where you tune the carbs together. It is a long time consuming process, but it is completely worth it, besides the fact that it looks kick-ass. I get a lot of compliments on it. I've actually had quite a few people try to buy the motor off the back of my boat, and that really makes you feel good. We've got, the handle is built out of the same thing as the shaft housing, and excuse me, I had it welded at first, and I realized that it's not necessarily the best thing to weld it in case you ever have to take it off, because whenever I ran all my wiring to my control box up here that has my key start, my tack, all my light switches, whenever I went to run all the wiring and I was trying to work everything around the motor, I realized it would be much easier if I could take it on and off. So it's got two 5/8 grade 8 bolts in it that hold it on. Works just as well as before. It's actually a little bit easier. That way if you ever have to take it off, you can take it off. You know, it doesn't take too much time or anything. Just an old pull throttle off of a tiller that we didn't need anymore at the house. Pretty much it. It's got about 10 hours on it. I put the tack on right after I got it. Barely past the break-in period, really. It's definitely a good investment. This is a 1448 1987 low. I have Gator Glide, the marsh mud Gator Glide on the bottom. This stuff is key in southeast Texas where I duck hunt, dealing with lilies. Anybody who hunts down here knows about water hyacinth. It kills you as far as getting to the holes that nobody else can get to. And let me tell you, that Gator Glide kicks ass whenever it comes to going over water hyacinth. That's pretty much it. I've tried to balance out all the weight in the boat to the center where I don't draft as much water. Put me a reverse light in here, reverse facing I should say. That's what that third switch goes to on the motor. That way I can have light inside the boat when we're pulling out decoys or getting the dogs unloaded or whatever we got to do for the day. Light bars, dualies that face outwards from back here. Where I hunt at, there's a lot of narrow sloughs and you're going through the marsh through a lot of different cuts and stuff. Really helps you out whenever you've got something that shines to the side, not just in the front, so you can watch the whole boat at the same time. But I'm actually looking to do a couple minor adjustments to it. I want to take it and cut, maybe, you know, trim this, shave on weight just a little bit. It's not that heavy of a plate, but any little bit of weight in a mud boat makes a difference. Just shave the plate, get the most strength out of it. Don't lose any of the tensile strength of it, but go ahead and, you know, shave a little bit of weight to help out on speed. Speaking of speed, with this boat fully loaded, myself, I mean, you can't really see me, but I'm a pretty big guy. I'm 6'1", 255 pounds. I've got a buddy who is aptly named Stump. He's a guy that you'll see in some of the videos that I'm going to be making this next duck season. He is probably 230, 240 pounds. He's a little bit shorter than I am. And with him, me, another guy that's way lighter, it's my little cousin, he's probably $150. Decoys, gear, guns, and everything, we can get about 19 miles an hour out of it, shallow water, and about 16 and a half, 17 deep water. Whenever you get in real shallow water, about 2 inches, I can get it up to 23 whenever it's not having to draft very much. But hopefully here soon I can get y'all a video of it running next day that I get to take it out. And hope y'all enjoyed it. If y'all have any questions on a build or anything like that, don't be afraid to message me, and I'm willing to help out anybody I can. So I hope y'all enjoyed it.